Hi guys, this is me, Peter. I'm sitting in my garage. Welcome to my garage. I was looking at my Tesla coil here, and I am thinking of running it with a pulsar that I just bought a couple of weeks ago. It's that thing here, and uh, it's actually not that easy to set the frequency on the pulsar because you have to get the duty cycle right as well, otherwise it won't show up on the oscilloscope. So I was going to test various top loads on my Tesla coil to determine just what the frequency was going to be set on the pulsar. This is the I'm also going to use a very low voltage because I have various experiments in mind that I can't do with high voltage. So the pulsar is actually only going to be running at around, I don't know, 20-30 volts, maybe a little bit more, depending on the duty cycle. Um, and the primary coil is going to be this thing here. Maybe I've got a few too many turns. Obviously when you pulse you don't want too much inductance giving you a kickback, because that may obviously damage the pulsar. I mean, there's gonna be a diode to protect it, but even so, I'm not sure that's gonna be enough to protect it. But I just wanted to point out a couple of things while I was finding the resonant frequency of the primary coil here. So I've hooked up my brand new signal generator, which I'm going to be using for other experiments as well, because this one here has now for the square wave, has a rise time of around 15 nanoseconds, which is what I need. And I've got my oscilloscope here, and I'm going to do a bit of tuning, and hopefully I can do that while holding my camera somehow. Let's see if that's even possible. I don't know. So let's see. I will squeeze the oscilloscope in my little finger here, and I'm going to turn the frequency knob down here, and we will check out what happens. Okay. So I'm gonna, yeah, here we go. Alright, I'm gonna detune it. I'm gonna get a little bit closer to the coil here. And now I am going to, so I'm at 729 kilohertz, and I'm going to raise that now. And you will see the voltage on the primary coil rise. Still rising, and now it's falling again. Okay, so let's go back to that. Okay, so we're talking 743. Now I'm going to run I'm going to run the tip of my scope needle here along the lines up and down the primary coil. Okay, I can't really show you that and the oscilloscope, but I'm gonna focus on the oscilloscope and tell you where the connector is. So it's all the way at the base now, and now I'm raising it about a third. Now I'm in the middle. Okay, I'm in the middle, and it's sort of the top right there. It's in the middle, and now I'm rising to the top. Okay, and as you can see, my highest voltage is right in the middle of the coil. Obviously, with a tuned secondary, that should not be. The highest voltage should be at the top of the coil, right? Now the reason why it's showing in the middle of the coil is because I'm sitting right next to it. I'm going to do the same thing again now, but I'm going to move away from my secondary. Okay. About, well, as far as I can handle it. I'm going to stand up, take it again, so I will start again now. I'm going to hold it a little bit further away. So now I'm at the bottom. I'm raising it now to about a third. Now I'm raising it to about the middle. And now I'm going to raise it to the top. And now I am at the end of the winding, and here I'm about 7/8 up, and that's where the maximum voltage is. And I would guess that if I wasn't around, the maximum voltage would be right at the top. So this is in line with, you know, the quorum papers that Smokey has posted, and in those papers it said that these guys have actually built a contraption to avoid, you know, their bodies being part of the equation. So they had some sort of a wooden arm with the oscilloscope point attached to it. Yeah, so much for tuning the secondary, and I am going to, you know, find a couple of interesting top loads now, and I guess I'll see you online. Let's see, is there anything else interesting around here? Not really. Okay, bye.